What I'd like to now talk about is finding inverse trig functions using our calculator. As a first example, I'd like to find sine inverse of 3 over 5. So let's do this on our calculators. The inverse buttons are gotten to by pressing second and then the function itself. And so when you press second sine, then that will get you to sine inverse. We wanted to compute 3 over 5. Sine inverse of 3 over 5 is 0.6435 if we round off to 4 decimal places. Okay, let's do sine of negative 2/3. Okay, sine inverse of negative 2/3. Do make sure that on these particular problems you're pressing the inverse and not the original function sine. Press enter. On this one we get negative 0.7297. Now, one of the things that you have to keep in mind if you're performing inverses is that most of the time they're going to want us to be in radian mode. If you're getting different answers than I am at this particular point, go to your mode and make sure that you're in radian mode. Recall how to do that. Go to mode, and then if you'll arrow down 3 places, you have radian and you have degree. Make sure that the radian mode is highlighted. Alright, now from here, there are some tricks when it comes to doing inverses that are not shown on your calculator. In other words, your calculator doesn't have a button for inverse secant. Now, the first thing I need you to know is what this is not equal to. The inverse secant of negative 9 is not equal to 1 over the inverse cosine of that number. So you need to make very, very certain that you have that down, that inverses do not compare as reciprocals like our regular trig functions do. So that's not equal 1 over cosine inverse of negative 9. What you want to do on these kind of problems is you want to think about if secant was equal to negative 9, then its reciprocal, cosecant inverse, would be negative 1/9. Okay, this notation is basically saying that secant of some angle theta is equal to negative 9 over 1. And so that being the case, then cosine is equal to negative 1 over 9. And so you can change it to inverse cosine and then take the reciprocal of the inside value. Okay, now the other thing that we need to consider is we need to consider the restrictions on these two functions. The restriction on inverse secant and inverse cosine are essentially the same thing. For secant inverse, the restriction is look at anything between 0 and pi over 2, not including pi over 2, pi over 2, and pi. The restriction on cosine inverse is anything between 0 and pi. The reason I have to keep this in mind is that my original question was find the value of secant inverse of negative 9. I'm changing that so that I can type it into my calculator to cosine inverse of negative 1 over 9. When I make any kind of a change, there's always the possibility that the restriction changed from secant to cosine. But in this case, because secant and cosine are reciprocals of each other, there's really no change to the restriction. The only problem that I would have is if I actually got the angle pi over 2, I'd have to say that's not a solution because it's not in the restriction of secant. So let's go to our calculator and let's compute this particular one. We want to perform cosine inverse of negative 1 over 9. Okay, that results in 1.6821. Okay, if we round to 4 places. Now let me verify to you what I'm talking about as far as the restrictions are concerned. This particular answer is an element of the restriction on secant inverse. And the way I know that is I know that pi is approximately 3.14 and so forth. Okay, and 1.682 is in between 0 and pi. And so I know that this fits inside the restricted area. As another example, let's find cotangent inverse of -3. Now I'm going to let you realize that on this particular example, I show you something different than what the book shows you. If you'd like to do the way the book shows you, that's fine. If not, here's another way to do it. Okay, on here, I don't have a cotangent inverse button on my calculator, so I'm going to convert this to tangent inverse, and I make sure to take the reciprocal of the number on the inside. That's the proper way to type this in our calculator. Now, there's been a change in the restrictions. For cotangent, the restriction on my angle is my angle needs to be in between 0 and pi. For tangent, the restriction on my angle is in between -pi/2 and pi/2. Because the restriction has changed, I need to pay careful attention to the value I get out, and I may have to adjust that so that it's a proper value for the original question, which was cotangent inverse. Let's go do this on our calculator. We would like to do tangent inverse of -1/3. Okay, when I get that, I get -0.32175/05544. And I'm just going to round for the moment. So this particular value, I get -0.3218. Let me get a few more decimals in that. I'll tell you what, let me do a 7505 there at the end. Okay, there were more decimal places. I'd like to take it to a couple because I'm going to need to do something else with this number. Okay, now, that particular angle value, okay, so remember that this is an angle. This value is not my answer because it's not in the proper interval from 0 to pi. So what do I do about that? Well, here's what I do. I use this as a reference angle, and I want to use it in absolute value. So I use -0.321750, which is positive, and I take the absolute value as a reference angle. Okay? And the idea is this. My original function was the cotangent inverse of -3. What that means is it means that the cotangent of some angle is equal to -3/1, or it could be 3/-1. Looking at the possible quadrants that the angle could be located, it being between 0 and pi, then I know that I actually need to be over in quadrant 2. So I can't have anything here and here. Okay, that being the case, then I see that I need to have my x being -3, y being 1. Now, I don't really care here about my r value. I could compute the r value if I wanted to, but my goal here was to determine which quadrant the angle's in that I'm looking for. It needs to be in quadrant 2. Okay? So using this 0.321750 as a reference angle, then you can see that what we need to do to figure out the angle from here around, which would be my answer, I need to take that reference angle and subtract pi minus that value. So on here, my final answer should be pi minus 0.3217505, and so forth. Okay, we'll do that on our calculator. So we're going to do second pi minus, now make sure you don't do second answer here because the answer we have up above is negative. We want to do pi minus positive 0.32175055544, and I'll use as many decimals as I can since it's in my calculator. That gives me 2.8198 rounded off. So here my answer, 2.8198. Final answer. Okay. On there, do be careful. This particular concept, I realize, is a little bit confusing. If you'd like to use my particular method, feel free to do so. If you would like to look at a different method, you can look in the text and it shows you a different method. Okay, this concludes my lesson on evaluating inverses on the calculator.